Moving on, we would like to invite Mr. Alex Au to share with us about a well-known open source observability stack called OpenTelemetry in Python. Alex is a cloud engineer with experience in production-grade ML and back-end development. Alex, please.
So good afternoon, everyone. So I'm Alex Au. So today I'm going to talk about how to operate with confidence, like when we use OpenTelemetry in Python. So here are some of my PowerPoint and also those GitHub page, GitHub link for this talk. So before we really start, so let's talk about like my background. So as MC mentioned, so I'm a software engineer and I do backend and also DevOps, and I also have some cloud certs. And currently I'm working in Chai, which is a remote startup, like in remote work in California. And I currently have 4 years of experience in Python, and I do Python mainly for like custom management and also like backend development. So cool. So like before we really start like what OpenTelemetry is, so let's talk about like what is observability. So imagine we are having a system. So how can we, like the system is ongoing, having a lot of traffic. So how can we understand the internal state of a system, which means that we want to know the health, the performance, and also like some current state. Maybe your Kubernetes cluster have some config map or some internal state that is not very easy to see. So what observability means is that it helps us to debug the distributed system or like some current modern infrastructure system that we mainly have. So in today's world, we always talk about like the 3 pillars of system observability. So first one is the log, and second is metric, and the third one is trace. So by its name, I think you might be quite confused. So what they like actually means. So let's imagine the following situation, that someone just got his or her lunch, and you see that guy is having happily of his fried rice. Yeah. So what log is actually is like the guy is talking about what has been eaten. So he can very like say detailedly, like I have a bag of curry and it is on the rice, or it has he had a like plate of pasta. So in some sense, log actually has a rich and contextual information. So which means that it has a lot of information about itself, and those information are that one can only know by himself. So because like every lunch can be slightly different, and it is only you that understand what the difference is. So this is meant by the rich contextual and also individual information. Okay, so talking about metric is more like some crazy numbers. So in some sense, metric is some aggregated numbers of the meal. So maybe he said, okay, over the last 3 days, we have I don't know how to pronounce those, like around like 50,000 rice grains, yeah, and like around like 5,000 spaghetto. Yeah, spaghetto is, yeah, I checked the dictionary, like spaghetto is actually the single form of spaghetti. So metric is basically is across a period of time, so bear that in mind. And what actually trace is like we describing what's the procedure of we having the meal. So he said, okay, within these 3 days, on average, I pick up my the spoon with my right hand for around like on average 2.04 seconds, and I mix the curry on average for like 8.12 seconds. Yeah, he is definitely a math maniac. And trace actually has a higher level like detail of the view than log, but it actually is much lower level than metric, because as you aggregate a lot of data for the metric, but like trace, we have the procedure of the process, but not very detailed. And yeah, and trace is actually a record the procedure of an event, just I've mentioned. Okay, so let's get to the actual coding and also technical part. So in our today's age of distributed system, and actually a single backend has really not a lot of sufficient details of the whole process. And it means like we usually have some API gateway and some source of services. So each services has its own local data and local state. And those data are actually stored inside the pod or the node, as like what you can call. But if we need to debug a whole system, it will be very painful because we have to aggregate a lot of data across different systems. So this is what the distributed trace, span, and also context propagation are about. So here you can see the illustration that the server 1 is calling server 2, and it is propagating something called the trace ID and also span ID. And for the server 2 to server 3, it is also like propagating this information. So I will explain in more detail what those data or those meaning are. But you can see like those three servers are actually sending the traces, metrics, and logs that we have just mentioned before to something called the OTel collector. To illustrate more like what is trace in our production system, so let's consider this following Gantt chart-like diagram. So for the horizontal line is about the time progression, and for the vertical line is something called the span. The meaning of span will be more clear later on, but you just consider it's like a sequence of something. So in our previous case, at the time that the span ID is 1 starts, actually we have a single server here. Then when it calls another server, and it will propagate its span ID and also a trace ID. So think of trace ID is the mother or like the parent of those spans. So like trace ID 1 and span ID 1, it will send to the server 2, and is where the process of server 2 starts. Then when server 2 calls server 3, and you can see the red line, the server 2 actually send its span ID as 2 and also the trace ID as 1 to the third one. And actually, you, if you can, you want to take a photo, actually better to just get the QR code, and you can get a much better illustration there. So for the same server, so I like denote it as the same color. So like for the server 3, it calls itself, or it has some process that relies on itself. Then it will propagate its span ID 3 to itself. And I think there's a typo here, should not be server 4 but server 3. Yeah, sorry for that, but you just think of a single color means a unique server. So span ID 3 and 4 actually exist in the same server, but they have different span ID. Okay, so we have talked about like distributed trace, log, and metrics. So let's talk about like why not just using logs, because I think like most of us have been using log, right? Even though we don't know, like in JavaScript we also have console.log, but it's actually print. But anyway, so why we use log, not only log, is like when you consider when your request is across different servers, what if the request doesn't arrive in downstream? So maybe there's packet loss, or like whether your downstream server actually denies that request. So there's quite a little information when your request or some process is across different microservices. And as I mentioned, like log is more like rich local context and have a lot of like flexibility to describe the system itself. So it is hard to perform something called the root cause analysis under high traffic use case, because you only see a single side of view of the system. So you only see the server itself, but not the whole system. And also the chronological order of the log may actually mix up together if you have a lot of traffic is coming together. Then you may also ask, okay, my company is using Prometheus, and like in Python, I use Prometheus client, and everything works right. So why not just use it? Yeah, actually, metrics is quite good for forecasting, but it is not very good for root cause finding, because what you can get actually is just a very high level number of numbers. As I said, I have eaten 50,000 rice grains, right, and those spaghettos. But it's very hard for me to understand which actual part of the system is having the error. So metric is too aggregate for pinpointing a problem, and it's not flexible to illustrate the system state, because it's just a bunch of numbers. And more importantly, it's more about the Prometheus itself. Prometheus is pool-based, so if you have you have tried integrating with Prometheus before, you will find that it's very hard to use with AWS Lambda or GCP Cloud Run, because you need to somehow you have a push gateway, and then you just send all the metrics there. If not, then when Prometheus create your server, it probably just killed because of some inactivity. So in short, Trace provides a big picture of the service overall performance. Log provides something useful for debugging some problems in local. So we have a lot of data that we know in our head, but not others. And metrics are best for the trend analysis. So this is at least what are the Trace, those three pillars of observability are. So going to today's world, observability system, I think you guys also, if you really work in a company, you will find this problem. Your boss is saying, oh, we have observability, we want to go there, and you say, oh, wow, what the hell. So what OpenTelemetry actually makes is it makes sure the telemetry are collected easily, correctly, and also efficiently. So how? So in the heart of the day, OpenTelemetry has two main focus. One is the OpenTelemetry collector, and another is the SDK. So OpenTelemetry helps us to standardize how the logs, metric, and the collection, and also the trace propagation. So about trace propagation or the actual code, I will show you later. But what important is that it helps us to do the standardization, and also it prevents vendor lock-in, because it allows different language to export to its collector, and it export to different kind of those observability backend. So to say more about the SDK, so we have just seen how OTel collector works. It just helps doing the pipeline. But the OTel SDK is actually the game changer in Python. If you really have tried writing pure trace in OTel without the SDK, the auto instrumentation, you will feel it's really painful, and you are fine. You might probably quit your job. So OTel SDK is something that it provides something called the instrumenter, and instrumentation means the process of using the tools. So whatsoever, it just helps you to reduce the lines of code, and it helps you to bring all the contextual data together, so that your log, metric, and also traces have the same trace or span ID. And thirdly, OTel SDK are push-based. So in my actual code, you can see a lot of things called exporter, and it sends to the endpoint. So this is what I have mentioned before. The OTel Python SDK export the data to the OTel collector. and it makes something in the pipeline flow, so it prevents the pool-based problem. So what about just have a look at a simplistic example? I think it's actually quite simplistic already, but maybe you find it difficult. So in the heart of the day, the API gateway is sending to MySQL the product price service and also product info service. So it is the API gateway sends the data to the product. The MySQL is because it has to get something called the product ID, and sends the request to product price service is because it has to get the product price, and for the product info service, it gets the product info, and you can see the subsequent or corresponding backend that I'm using. So in this example, those three services will also send the traces, logs, and also metric into the OTel collector. So let me just switch to what about I just talk about the backend first. So previously we have saw that OTel SDK actually helps us reduce the lines of code, and it's actually the case in our code. So if you can see like the photo at the left, and it says like set up PyMySQL instrumentation, set up HTTPS instrumentation, set up fast API instrumentation, and so on. So if you have really tried like writing some Prometheus metric, you will find that either you have something called some wrapper to help you route or create those metrics, or you just have to add every counter histogram to your API endpoints. So the instrumenter is more like having you wrapping everything, and it patches those libraries. So let's say you set up PyMySQL instrumentation, it patches the PyMySQL library so that when you call the MySQL to get or select, and actually it helps you to record the trace. So at the right, so you can see there are I set up the traces, the metric reader, and also the logger. And as I mentioned, all of them are exporters. So let me see. So now I'm actually like calling the API. Anyway, it is just for generating some server data. So it's really not that big deal. But let me see. Okay, I can't move right now. Oh wow. Oh. So okay. Probably because I have moved it to see. And at the back, so I actually set up the OTel collector connecting to the Grafana, and also the Grafana has a low-key Prometheus and Tempo. But for Prometheus, actually it doesn't do really much, because like OTel actually needs to write to something called the remote backend for Prometheus. So in today's demo, I can't actually show like how Tempo is connected to Prometheus. So in the Explorer page, so let's split it first. So Tempo is something called like the trace selector. So it helps us to select the trace. So just now you can see that there are a lot of trace IDs, and underneath there are span IDs. So those are the stuff that I've mentioned, like you have the trace, and then the trace means a single process. The span means in the microservice level, those process. And you can see that the duration, those are either in like millisecond or in second. So if you are very enough, so probably you have to see those y are in seconds. So here you can see the graph that a single process is executing quite long. So why? The best thing of setting OTel is like once you have set it correctly and use it the instrumentation correctly, and the whole process, actually you can see the whole Gantt chart across distributed system. So here you can see there's something called the hgetAll. It's actually calling the Redis. And in API gateway, here is a very long process, around 1.2 seconds. It's calling the product price service. And to actually see why it is running that long, so let's see. So if you set the OTel correctly, and if you click the button called connect to the log, and because the OTel has add the trace and also span ID to your log together, so that if you are tracing through the trace, you can actually see the log correspondingly. So you can see that maybe I just clicked on the wrong span, but in the full trace, you can see that why it's running that long is because I have done something called the delay injection. So I just normally add a sleep for 1.2 seconds so that it makes the thing long. So if you set it correctly, not only you can use the trace to see the log and to find out the root cause, and you can also have a very high overview of getting something called the service graph. So in Grafana, you can see here, this is the whole service I'm setting up. So there's a user that calls the API gateway. And the red one means I'm now having around like 35 or like 30% of error rate. And those error is due to the product info period. And so that the API gateway also get error. But for MySQL, the price period and also the Redis, there's no any problem at all. So if you set it up correctly, then you can get this beautiful graph that you can show off to your boss and also tell them, yeah, our system looks great, right? Yeah. Okay. So we have talked about Grafana dashboard, those instrumentation, and joining the logs and traces. Okay, so it's graph, good. So before we actually end, so just now we have talked about like Prometheus is actually tool-based, but so that it doesn't work well with the AWS Lambda or CloudRun. So actually, AWS has also provided something called the AWS distro for OpenTelemetry, that it allows you to run something, set up a config, and run OTel inside your Lambda. So what it basically do is that you set up the layer and also set up the environment variable. And then if you just trigger the Lambda, and you can actually see the log, maybe if your eyesight is strong, yeah. So you can see at the start, it says, okay, telemetry API client is activating. And here, you can see even the Lambda has end the request, and normally it should stop and like don't send any traffic, right? So because AWS has something called the telemetry API, so it runs like a on top of Lambda, that a extension wrapper that allows it to run after the AWS Lambda has finished its runtime. So this is how great that AWS and other cloud platform embraces OpenTelemetry, because it helps us to like provide a push-based solution, and also it runs well on the serverless compute. So about for the other platform integration, so we have a lot of different cloud providers are setting up OpenTelemetry thing like X-Ray and also CloudTrace like that. So you can just check out that out. And also thanks to OTel collectors pipelining nature, and you can actually see when you send the data over to other destination, there are a lot of choices for you. But don't just trust me blindly, because not every telemetry or every traces are really important. So like if you just add auto instrument to every project, then you will like stomp. So for the cost control, actually there's something called this parent-based trace ratio that you can just do some random sampling. And also in OTel collector, you can just do sampling in this batch processor. And the second one is always like do the data retention and also find some common like cloud native persistent blob storage like S3. If you use like Mimir and like Tempo in distributed system, then you will definitely get a good amount of cost like reduced. So in summary, so we have talked about like 3 pillars of observability, and you also see the cool graph and also like the demo with Grafana, and you can show off with your friend. And in the heart of the day, OTel mainly have 2 components, the collector and also SDK. So collector is for pipelining your stuff so that it do the push phase, and SDK is doing some auto instrumentation that adds the trace to your log and also metric. And remember, always remember, sample useful telemetry data. If not, you will probably lose your job because of spending too much money. So reference, so special mention that like here, the third one, that guy is very good, great, because it helps me the connection issue that I nearly have gone crazy for 2 days. Yeah. And finally, is Q&A about like OpenTelemetry. So if you guys have any questions, just feel free to like ask me, or I'm also happy like after the session. Yeah.
Thank you. Any questions? Yes.
We are doing the push data in OpenTelemetry, right? So like any other network requests means it can fail. Is there any way to set up the retry policy or anything like that, so we have more guarantees that it will actually send?
Yeah, so actually the OTel like traces or those stuff are actually like running inside your Python, right? So whenever there's really some networking issues, so let's say it cannot send the traces, then actually it will store inside your memory until it really like have some memory issue with the whole process. So as long as like you have probably like garbage collected your program and just left those trace data, and probably it's good if it is just momentarily off. But like as I mentioned, like if you are like running on Kubernetes and you do auto instrumentation for every endpoint, every traces without sampling, then I think like at some point in Kubernetes your pod memory will goes out and just die. So definitely have to like check on that, and also sometimes just leverage some like better solution. Don't always build everything by yourself, and this is what I learned from my previous job. Yeah. So any other question?
If not, thank you, Alex, again. Next session will be at 3:15.